This presentation will be very short. We're going to examine DC gain. The DC gain is the gain of a transfer function at zero frequency. That is, we set S equal to 0. So the DC gain is the magnitude of the transfer function evaluated at 0. And I've written it here as the DC gain is the absolute value of G of J0. This is the amplification that a signal which is a cosine at zero frequency gets when it goes through the system. Let's look at what a cosine at zero frequency is. If we set the frequency omega to 0, then cosine 0t is just 1. That is, x of t would be a constant signal for all time. That's what a zero frequency signal is, a non-causal constant signal. If we apply that constant signal to a transfer function g of s, which is the ratio of two polynomials, as shown here, then we'll find that DC gain is the absolute value of b0 over a0, where b0 is the last coefficient in the numerator polynomial and a0 is the last coefficient in the denominator polynomial. So it's really very easy to see how much amplification a constant signal receives when it passes through a system. The amplification is just the absolute value of the ratio of these two coefficients. So we know how a system responds to a constant input, a non-causal constant input. What about how it responds to a causal constant input? That would be a unit step. The causal cosine is x of t is cosine omega t u of t, and the unit step is x of t cosine 0t u of t. We know if the system is stable that the output to a causal cosine will converge to the output to a non-causal cosine after some transient has died out. What that means is that the output to a unit step will converge, if the system is stable, to the output to a non-causal constant signal. We just learned that the output to a non-causal constant signal was easy to find. We just needed to multiply the amplitude of the input, that is the constant, by the DC gain of the system. And the DC gain was easy to determine. That means we can find out what the response is to a unit step after the transient dies out in a very easy way. It will just be the DC gain times the amplitude of the step, in this case 1. So, for a stable system, we know the output in response to a unit step input will, after the transient dies out, have a magnitude equal to the DC gain of the system. For a stable system, the phase at zero frequency will either be 0 or 180 degrees. That means that the constant value that the output achieves after the transient dies out can either be equal to the DC gain, in the case that the phase is equal to 0, or will be equal to the negative of the DC gain, in the case that the phase is equal to 180 degrees. In either case, the amplification of the input signal, that is a unit step, is just the DC gain. The only difference is whether the output has the same sign as the input or has the opposite sign, in the case that phi is equal to 180 degrees. This finishes our discussion of DC gain. The important things to realize about this topic is that the DC gain is the amplification a signal that is constant receives when going through a system, and that the DC gain is easy to calculate from the transfer function. It's just the magnitude of B0 over A0, where B0 and A0 are coefficients in the numerator and denominator polynomials. And finally, that the response to a unit step will have a magnitude that is equal to the DC gain.